Intensive practice 5.2, question 1. Calculate the number of terms and sum for each of the following geometric progression. Okay, so they gave us the last term. We need to find how many terms to get to this term. So this is our Tn. We need to find the value of n. So which term is this lah? Then we need to find the sum. Okay, so since this is a geometric progression, we use the geometric progression formula. So for geometric progression, Tn is AR n minus 1. Sn will be A Rn minus 1 over R minus 1. This will be our formula. Alright, let's look at A. So first we need to find what is A and what is R. A in this case is just the first term lah. So it's just negative 1. R will be T2 over T1. So we write T2 over T1. T2 is 3. T1 is negative 1. So R is negative 3. Alright. Now we can find n. So we know the nth term is 2187. So AR n minus 1, 2187. We know the values of A and R. So negative 1, negative 3, n minus 1 is 2187. So negative 1, we bring it over here, becomes divide negative 1. So we'll get negative 2187. Since both sides got negative, we can cross out the negatives. So erase this. And this is 3 to the power of something. 2187 also can be made 3 to the power of something. So we can try 3 to the power of 8. No. 3 to the power of 7, yes. So 3 to the power of 7 is 3n minus 1. Therefore, n minus 1, we can compare it with 7. So n is 8. Okay. So this will be the 8th term. So we have 8 terms in this sequence. Right. Done. Next, we need to find the sum of the 8 terms. So Sn would be this formula. So S8, here we put 8. So we just sub it in lah. A R to the power of 8 minus 1 over R minus 1. Oops. Negative 1 times negative 3 power 8. Actually, this one you have to put bracket. Negative 3 power 8 minus 1, close bracket, and then negative 3 minus 1. So we get 1640. This will be the sum of the first 8 terms. Done. Okay, let's try B. Okay, so we do the same thing. We identify what is A, what is R. So A is quite clear, it's just this. Log x negative 1. R will be T2 divided by T1. So we can say log x negative 2 over log x power negative 1. Okay, since this is log, these powers we can bring forward. So this will give us negative 2 log x over negative 1 log x. So these logs we can cancel off. Negative 2 divide negative 1, we get 2. So A and R done. Right. Next we need to find Tn. So Tn, the nth term is this, log x negative 64. Okay, so Tn is arn minus 1 equals to log x negative 64. So A is log x negative 1, R is 2, n minus 1 equals to log x negative 64. Okay, so we leave the 2n minus 1 here, we bring this log over here. So this becomes log x negative 64 over log x negative 1. And then the negative 64 and the negative 1 we can bring forward. So this will become 2n minus 1 is negative 64 log x over negative 1 log x. These two can cancel off, leaving us with just 64. And 64 we know it's 2 to the power of 6. So 2n minus 1 is 2 power 6, therefore n minus 1 is 6 and n will therefore be 7. So there are 7 terms in this sequence. Okay. Now let's try to find the sum of these 7 terms. Okay, let's try to find S7. So we know Sn follows this formula. So S7 means we just sub this with 7. So A is log x negative 1 Rn minus 1 over R minus 1. So this negative 1 we can bring forward. We get negative log x 2 to the power of 7 should be 128 minus 1 will be 127. So this will be 127 divided by 2 minus 1 is just 1. So over 1 no need to write. And then we can write this as negative 127 log x. So this will be our S7, the sum of the first 17 terms. Or if you want to bring this 1 to 7 up here also can. So let's just try to bring it up here since all of our terms has the power on top. So 1 to 7, if you bring it on top, it will look something like this. Log x negative 1 to 7. Done. But if you leave it in front also same, because it means the same thing. That's it. Okay, B done. Alright, let's try C. Okay, same thing. We identify our A and R first. So A is 0.54. R will be T2 divided by T1. So 0.0054 divided by 0.54. Oops. 0.0054, 0.54. 0.01. Okay. So now we need to find Tn. So Tn is this. 5.4 10 power negative 17. So ARn minus 1 is 5.4. A we know, A is 0.54. R is 0.01. And then 0.54 we can bring it over here. So we are left with 0.01 n minus 1 is 5.4 divided by 0.54. So here 5.4 times 10 power negative 17 divided by 0.54. We get 1 times 10 power negative 16. That's a very small number. Okay. What can we do is, we can actually try to guess what is this in 0.01 to the power of something. But instead of guessing, what we can do is we can try to use log. Okay, so log is a guaranteed way to get it. So both, not say both, the whole equation we multiplied by log 10. So we'll be left with log 0.01 and minus 1 is log 1 times 10 power negative 16. Why we times log? So that we can bring the power down. Then we can find n. So this will be n minus 1 log 0.01 equals to log of this. Then this log 0.01, we bring it over here, it will become divide. So n minus 1 is log of this divide log 0.01. Log 1 times 10 power negative 16 divide log 0.01. We get 8. So if n minus 1 is 8, n will be 9. So we have 9 terms in this sequence. Done. Okay, now we need to find S9. So let's erase all this. Right. N is 9, so we need to find S9. S9 means this will be 9 and this will be 9. So A r power 9 minus 1 over r minus 1. 0.54 times power 9 minus 1 divide 0.01 minus 1. Oh, that's a long number. Can we change this to fraction? Can't seem to find fractions, but this, I don't know why my calculator is not showing, but basically this will be 6 over 11. Something wrong. Yeah, 6 over 11 is the same answer. Okay, you should get 6 over 11 in your calculator. I think the white one should give you 6 over 11. Done. So this is the sum of the first 9 terms. All right. Okay, let's try D. So same thing. A is 3. R is T2 over T1. So 3 over 2 divide by 3. 3 over 2 divide 3, we get 0.5. All right, let's find Tn. So Tn is given as 3 over 64. So ARn minus 1. A is 3, R is 0.5, 64. Okay, then 3 we bring here, becomes divide. So 0.5 n minus 1. 3 divided by 3 over 64 will get 1 over 64. I'll just show it to you guys. Divide 3. 1 over 64. Okay, then here we can solve it without log, but I'm just going to show you the log method. Okay, without log is basically like this. I'll show you this also. So 0.5 is basically 1 over 2. So we must know that 2 to the power of 2 to the power of 6 is 64. So then, okay, let me just show you that method. So 1 over 2 n minus 1. This 64 will become 1 over 2 power 6. So if you do 1 over 2 to the power of 6, we get 1 over 64. So we can convert this to 1 over 2 power 6. Then we can just compare the powers. Okay, but let's say if you don't know, what you can do is you can just multiply log and find. So we multiply both sides by log. So log, oops, wait, log 1 over 2 n minus 1 equals to log 1 over 64. And then this power we can bring it down. So n minus 1 log 1 over 2 equals to log 1 over 64. So then this one we can bring over here, become divide. So log 1 over 64 divided by log 1 over 2, we get 6. So you can say this is 6, therefore n is 7. So we have 7 terms in this sequence. To be honest, the log method is quite long, but if you are really good with numbers, if you can quickly identify that 64 is 2 power of 6, then you can just use 2 power 1 over 2 power 6, then you can compare the powers super fast. But if you can't quickly realize, then log is the best option. Alright, so we have n is 7. Oops, I erased the wrong thing. Okay, now we need to find Sn. S7. So S7 would be 7. So here will be 7. So A R power 7 over, oops, over 0.5 minus 1. So I put all of these in our calculator. Oops, minus 1, 0.5 minus 1. We get 381 over 64. This will be the sum of our first 7 terms. Done. That's it.